Hello students. In the today's lecture we are going to discuss about the graphical method of determining the principal stress. In our last lecture we talked about the analytical method to determine the principal stresses. We were given the value of the state of stress, that means we were knowing the value of, let's say, sigma x, sigma y and tau xy, and then using those values we needed to find the forces which are caused by these stresses, and then resolve the forces along and perpendicular to the plane on which we want to find the stresses, and thus we find the value of principal stress and its plane also. So that was the analytical method where the resolution of forces were used. This is a graphical method. Surprisingly, this method is far more easier in comparison to the analytical method that we have used. A German engineer named Otto Mohr developed this graphical method. So that's why the name of this graphical method is based on his name, and it is called as Mohr's circle. So there are certain steps to apply this graphical method, and let's look at that what are those steps are. So as I just said that in a case of a biaxial state of stress, we are given the value of the stress acting along the x direction, which is sigma x, acting along the y direction, that is sigma y, and the state of shear, that is tau xy. So we know the value of sigma x, sigma y and tau xy, and we wanted to determine the value of sigma 1 and sigma 2, which are our principal stresses, and the maximum shear stress tau max, and perhaps the angle of the principal plane. So the steps involve using the data that are given to us. So first we have the coordinate axis plotted, like here the origin is shown as O, and we have the x-axis marked as OX, and the vertical axis is marked as OY. We choose certain scale, and whatever the value of sigma x is given to us, let's say if it is, let's say, 100 megapascal, so we choose, let's say, 10 megapascal is equal to 1 centimeter. So we will mark on the scale on the x-axis the value equal to 10 centimeter, which represents the 100 megapascal value of sigma x. So we need to choose a scale to plot the value of sigma x, sigma y and tau xy and so on. So after choosing that scale with origin, we draw the value OM1 and OM2, which are equal to sigma x and sigma y respectively on that scale. After that, finding the value of position of M1 and M2, which are shown here like these points. This is the M1 and this is the M2. We will draw M1 L1 and M2 L2 perpendiculars to OX axis, horizontal axis, and the value of L1 M1 and L2 M2 should be equal to tau xy. Okay, so what we have done, we have taken x-axis. On the x-axis we have marked the point M1 and M2, which corresponds to the value of sigma x and sigma y respectively. From point M1 and M2 we have drawn the verticals on the x-axis, which are L1 M1 and L2 M2, and the value of L1 M1 should be equal to the tau xy, and L2 M2 should also be equal to tau xy. Okay, so L1 M1 is above the x-axis and L2 M2 should be below the x-axis as shown in this figure. After doing this, we will join the point L1 and L2. Okay, so we have the point L1 here, we have the point L2, so we join them by a straight line, and this straight line will cut the x-axis at a point named C. We call this point where it is cutting the x-axis as point C. After this, we will take the C as the center and then choose the CL1 as radius. Okay, so we'll use a compass, and then we have the CL1 as a radius, and then we will draw a circle using that radius. Okay, so with C as the center and CL1 as the radius, we will draw a circle which is shown here in red in this figure. So we have drawn this circle here. This circle will cut the x-axis at 2 points. One is point R and another is point N. So it is cutting, this circle is cutting the x-axis at 2 points. which are R and N respectively. Now we will measure the value of R point from origin, that is called OR, and N point from the origin, that is ON. The value that we have measured for the OR will be equal to the sigma 1, and the value that we will measure for ON will be equal to sigma 2. That means the first principal stress and the second principal stress respectively. So we will find that okay, OR is this much centimeter. You convert it back to the megapascal using the scale that you have chosen, and so you will find the value of sigma 1, and same way you can find the value of sigma 2 as shown here. So this is your sigma 1 and this is your sigma 2. The radius that you have taken, the CL1, this is going to be equal to your value of maximum shear stress, that will be called as tau max. Okay, and the angle L1CM1, which is here being made, that will be equal to twice of theta. Okay, twice of theta means twice the value of the principal stress angle from the sigma x. So if you want to find the value of the angle of principal plane, then you need to just divide the value of angle L1CM1 with 2, and you will get the value of theta from that. Now this is what we are going to do, how the construction will look like and how we are going to measure the values. But let's look at the proof of that OR will be equal to sigma 1 and ON will be equal to sigma 2 and CL1 will be equal to tau max. So let's look at this proof. So from this figure we know that as we have drawn the point OM1 equal to sigma x and OM2 equal to sigma y, therefore the point C, which is exactly at the middle of M1 M2, so CM1 and CM2, they both will be equal, and that will be equal to sigma x minus sigma y divided by 2, because M1 M2 is equal to sigma x minus sigma y, and CM1 is half of the M1 M2, so that's why CM1 will be equal to sigma x minus sigma y by 2, and similarly CM2 should also be equal to sigma x minus sigma y by 2. So this is what our first equation is saying. The value of OC, that means the distance of point C from the O, can be defined as OM2 plus CM2. This is our M2, so this is OM2 plus CM2 is equal to OC. Now OM2 is nothing but our sigma y. This is how we have plotted the point M2, so that's why OM2 is equal to sigma y. CM2 we have just defined as sigma x minus sigma y by 2, so their net sum will be equal to sigma x plus sigma y by 2. Now let's look at another distance, that is CL1, that is the radius of the circle. Now CL1 can be defined from the triangle L1CM1. This is the triangle we are talking about, L1CM1. So from this triangle we know that CL1 will be equal to under root of CM1 square plus M1 L1 square. And what is the value of CM1? This is sigma x minus sigma y by 2, so we put it here, and M1 L1 is our value of tau xy. This is how we have plotted the value of distance of M1 L1, so that is equal to tau xy. We substitute it here, and so your formula for CL1 will be equal to under root of sigma x minus sigma y by 2 whole square plus tau xy. If you can remember from our last lecture, this is the value of the maximum shear stress that we calculated through analytical method. So the radius of the circle gives us the value of maximum shear stress or tau max. Now CL1 being radius is equal to CR, which is also another radius, and which is also equal to CN, which is the radius of the circle. Now we can define the value of OR, that means distance between point O origin and the point R where the circle is cutting the x-axis. So OR can be defined as OC plus CR, that means OC, the distance here, so O to C, and plus C to R. So we are saying that OR is equal to OC plus CR, and the value of OC we know is equal to sigma x plus sigma y by 2. Let's substitute here, and as CR is equal to CL1, and value of CL1 is already given over here, you substitute it here, so that gives you OR as sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 whole square plus tau xy square. Now you must remember that this is the value of the principal stress sigma 1 we calculated in our last class, so this is equal to sigma 1. So OR is basically equal to sigma 1. Similar way, we can define the value of ON. So ON will be equal to OC minus CN. You just please see here, this is O, this is C. So we are trying to define the value of ON. ON is this distance. So ON is basically OC minus CN, this distance, OC minus CN. Now you know the value of OC, that is sigma x plus sigma y by 2. You know the value of CN. CN is also equal to CL1. So you substitute the same under root values here. And this value corresponds to the second principal stress value. That's why it is equal to sigma 2. So in this way, we can see that we have find the value of tau max by the radius of the circle. We have find the value of first principal stress by measuring the value of OR. That means where the circle is cutting the x-axis. And we can find the value of sigma 2 by finding the value of ON, which is the another point where the circle is cutting the x-axis. Now what remains is the angle. Now angle L1 and R will be equal to twice of the angle, the L1 and R will be equal to half of the angle L1C M1. You can see here, this is L1 and R and this is L1C M1. So from the property of the circle, we know that L1 and R will be half of the angle L1C M1. As I just told you that angle L1C M1, what will be its value? Let's see there. So L1C M1, from the triangle L1C M1, if I define this angle here as 2 theta, angle L1C M1 as 2 theta here. So in that case, I can say that tangent of 2 theta is equal to L1 M1 divided by C M1. So this is what I have written here. Tan 2 theta is equal to L1 M1 divided by C M1. What is L1 M1? L1 M1 is given here. That is the distance, sorry. Just a moment. L1 M1 is your distance tau xy. So this will be equal to tau xy. And what is the CM1? CM1 is equal to sigma x minus sigma y by 2. So if you substitute it here, it becomes 2 times of tau xy divided by sigma x minus sigma y. You must remember this formula that we calculated the value for tangent of 2 theta P. So P was the subscript I gave for the principal stress angle, plane of the principal stress. So this is equal to tangent of 2 theta. So how in this way you can calculate the angle value of 2 theta using this figure, and then you can half it to find the value of theta from here. So this is the proof of Mohr circle. And now let's look at some numericals and see how we can apply the Mohr circle to solve some problems. So let's start with a very simple problem, and we have been given the value of sigma x and sigma y and tau xy in a numerical. You may be given some kind of a description, verbal description, that a component is there which is applied by a load of let's say the stress of this magnitude on one direction, stress of this magnitude in another direction. It is also subjected to simultaneously to the shear. Please find the value of the principal stress and maximum shear stress and so on. So from that all descriptions, I have just given you the data which you need to pick up. So what are the data which are given to you are basically the value of sigma x and sigma y. Apart from that, you are given the value of tau xy, and you need to find the value of principal stress and maximum shear stress. So what we are going to do, we will take a graph paper, and using that graph paper, or maybe on a plain paper, we will choose certain scale. So let's choose a scale of very simple scale of 10 mega Newton per meter square represents 1 centimeter. So first of all, we will find and locate the point M1. So OM1 is the distance we will measure with the scale, and at 10 centimeter we will mark the point M1, and then we will again from the origin we will measure the distance of 2 centimeter and mark the point on M2. So these 2 points represent the sigma x and sigma y value. Now from point M1 we will draw a perpendicular line, and from that perpendicular line we will cut the value of 3 centimeter, so to represent the tau xy value, which is 30 mega Newton per meter square. Similarly, we will draw a vertical downwards and we will find the point L2, which is again at the 3 centimeter distance. We will join the point L1 and L2 by a straight line, which will cut at the point at the center, which is C, and using the C as the center and L1 as the radius, we will draw this circle. So this is the circle we have drawn, and this circle will cut here at point R and N respectively. We will measure the distance OR here and we'll measure the distance ON. So this is what I have written here. The distance OR is equal to 11 centimeter. So if you multiply it back to using that scale, you will find that it is equivalent to 110 meganewton per meter square. And the distance ON is equal to 1 centimeter, and if you again multiply it with the 10 meganewton per meter square, you will get basically the value of sigma 2, which is 10 meganewton per meter square. You can measure the radius of this circle, which is CL1, and you will find that the value will be here 5 centimeter. Again you can multiply it by the 10, so you will get the Tom X maximum shear stress value as 50 meganewton per meter square. So by this data you can easily draw this circle and identify the value of sigma 1 and sigma 2 and also the Tom X. I would suggest you also use the analytical method, that means the formula we derived in our last class, and substitute there the value of sigma x, sigma y and tau xy, and see whether you get the same values from the analytical method or not. Please do this, take these values and make this circle, Mohr circle, on the graph paper. It is a kind of a home assignment for you here. Now let's look at another problem. In the previous problem, both sigma x and sigma y are of the same nature. They both were tensile here. Right now, in a case or a situation where one of them is tensile and another is compressive in nature, how are we going to draw the Mohr circle? So this is the problem in which sigma x value is given to you as 50 meganewton per meter square or 50 megapascal, which is tensile, and the second value sigma y is given as 30 megapascal or 30 meganewton per meter square, but it is a compressive in nature. And of course we are given some value of shear stress here, and we need to find in this question the principal stress, maximum shear stress, and the plane of the principal plane angle. So how we are going to start here? So in this case, again we need to first thing is to choose the scale. So we represent 10 meganewton per meter square as 1 centimeter. We take a graph paper with mark the horizontal axis OX and OY on that graph paper. Let's first start with the value of sigma x. So you take the value and find the value of on the right hand side of the origin as 5 centimeter, and OM1 will be equal to your representing the sigma x value. Then you take the value of 3 centimeter and you go to the left hand side of the origin, that means on the negative of the x-axis, and you mark the point at 3 centimeter distance from the origin of the point M2. So this way you are going to mark. So tensile value will be represented on the positive side of the axis, that means right hand side. The compressive stresses will be represented on the left hand side. So this value will come to the left hand side, M2 point will come to the left hand side. After doing this, we will do as before, and we will mark the value of tau xy, that is 25 meganewton per meter square. So we will take 2.5 centimeter and draw a vertical of 2.5 centimeter at point M1 and M2. So then this way we will get the value point L1 and L2. We will simply join the point L1 and L2 by a straight line, and we will get the point C, where it will cut the horizontal axis or x-axis. Now using the CL1 as radius, we will draw this circle here, which is shown here. This circle will cut at the point R and point N. Okay, so you can see from this figure, this circle is cutting at point R and N. We will measure the value of OR and ON. Now if you measure the value of OR, it will be something like 5.8 centimeter in my figure. So you multiply it by 10, so you will get the 58 megapascal or 58 meganewton per meter square value for the principal stress. The another value that we will measure is the ON. So if you measure the ON from this figure, this will give you the 3.8 centimeter value, which is equivalent to 38 meganewton per meter square. You see, this is on the left hand side as we have measured, so this will be a compressive in nature. So this principal stress, the first principal stress 58 megapascal, is tensile because it is on the right hand side of the axis, on the positive side, and the second principal stress value 38 megapascal is on the left hand side of the origin, so that's why it is a negative value and it is compressive in nature. So one principal stress is tensile, another is compressive in this case. In order to find the maximum shear stress value, we will measure the value of radius of this circle, that is CL1, and in this case it is 4.7 centimeter, which is equivalent to 47 meganewton per meter square. Now to find the value of the angle of the principal plane, we will measure the angle L1CM1. So this is the angle we are going to measure, L1CM1, and we are going to call it equal to 2 theta, as we have just proved that earlier. So this angle is equal to 32 degrees. So 2 theta is equal to 32 degree. So the angle of principal plane will come out to be here as 16 degree. So we can calculate it. Now let's look at another example. So in the previous two examples that we did, we were given straight away the value of sigma x and sigma y and tau xy, and we were supposed to find the value of principal stresses, their planes angle, and the maximum shear stress value. In some other cases, you may be provided some other data. Like for instance, you may be given the value of principal stresses, you may be given the angle at which they are acting on this particular case, and you need to find the value of the state of stress. That means you need to find the value of sigma x and sigma y and the tau xy value, which are not given to you. So this is the kind of a reverse problem here. So these all kind of problems in which the data are given in other forms, they are very easy, far more easier to calculate using this graphical method in comparison to analytical method that you will see for yourself here. So in this particular case, you are given the value of principal stresses sigma 1 as 60 megapascal, which is tensile, and sigma 2, which is 20 megapascal, which is compressive, and you are also given the angle at which the principal plane is inclined with the sigma x, that is 20 degrees. So these three data are given to you. Mind it, to draw the Mohr circle, you are always going to need at least three data. So in the previous case, it was sigma x, sigma y, and tau xy. In this case, it is sigma 1, sigma 2, and the angle. It might be you have been given sigma 1, sigma 2, and the tau max values, or it may be some other data forms. But always there should be at least minimum three data to be provided in order to determine the remaining data from it. So in all the cases, you can draw the Mohr circle if at least three data are given to you in a problem. So here you are given the principal stress values as well as the angle of that principal plane, and you need to find the value of sigma x, sigma y, and tau xy in this question. How we are going to start? Again, we will choose certain scale. So let's say the 10 megapascal is equal to 1 centimeter. I will first locate the point R. Okay, so I will mark the point distance OR equal to 6 centimeter, which is my first principal stress. And then because the another principal stress, second principal stress, is compressive in nature, so on left hand side of the origin, I will mark the point N, which will be at 2 centimeter distance from the origin. Once I have got the point R and N, I will locate the center point of it. So that is easy, just measuring Rn and finding the middle point of it. Rn will be obviously equal to 8 centimeters, so half of it will be 4 centimeters, so this OC distance will come out to be like 2 centimeters, so that you can easily locate here. So once you got the point C, from the point C, because the angle of the principal plane is given as 20 degree, you will draw a line LL dash. So I have drawn this line LL dash at 40 degree from the horizontal or the x-axis by using the point C as the center. Okay, so once I have drawn this line, okay, so from C we have drawn this line here, I will use the CR as radius and draw this circle. Okay, so this is the circle I have drawn here. I have taken CR as my radius, CR is my radius, and then I have drawn this circle. This circle will cut the line which I have drawn at 40 degree at point L1 and L2. Now once I have got these points L1 and L2, I will draw verticals from these points on the horizontal axis or x-axis, which will meet it at point M1 and M2 respectively. So now I have got my complete Mohr circle. What left is for me is to measure the values here. I will measure the value distance OM1, which is 4.9 centimeter as I measured it here, equivalent to 49 megapascal. This will represent the sigma x. I will measure the value of OM2, which is 1 centimeter in this case, equivalent to 10 megapascal, which will give me the value of sigma y here. And then I will measure the value of L1M1, which is this distance here. So I will measure the L1M1. This is 2.5 centimeter. This is equal to 25 megapascal. This gives me the value of tau xy. So you see, it is so easy to calculate, to draw these Mohr circle using any set of three data which are given to you, and to determine the other values which are not given to us. If you use the formulas for, like, say, analytical method, you can still do the same computation, but you will find that solving the question number 6 will be quite cumbersome using that. Please try to solve it analytically and also graphically the same problem which I have given to you. This is as your home assignment.